Hello students, in this video we will discuss the time dependent perturbation theory of chapter number 7. Okay, then we will start the types of the perturbations theory. Okay, there are the two types of the perturbations theory. They depend upon on the nature of problems. Okay, the first one is the time independent perturbations theory, which have discussed in the previous video. Okay, and the next one is the time dependent perturbations theory. Okay, in this case the Hamiltonian depend upon on times. Okay, in this case which is not depend upon on times. Okay, now then the potential energy function, which is the independent of time, is we can write like this, is R T, which is independent of time. Then the V only is depend on R, not dependent on T. Okay, now then the time dependent Schrodinger equations, which is H psi is equal to iota H cut and D psi divided by D T, which is the time dependent Schrodinger equations. Okay, now we put the value of H, which is the Hamiltonian, is the total energy, and then this is minus H cut square divided by 2m and D divided by dx square psi, and then plus V psi is equal to iota H cut and D psi divided by dt. Okay, this is the Schrodinger equations, the time dependent Schrodinger equations. Okay, now for the separable of variable, we consider the psi, which is depend upon the both the x on times, and then we separate, we write as small psi, which is depend only on x, and then phi, which is only depend on times. Okay, and looks here, first look here, this is the derivative with respect to time of the psi only first times, and then we take the derivative of the psi as capital psi and d divided by dt is equal to, we take the derivative of these sides, then this is constant psi x, and we take the derivative of this, which is the d t and the phi. Okay, here is derivative is the complete derivative, because this is only depend upon on time, and here the psi is what depend on the x and t, so we can write partial derivative here. Then we take the derivative of this wave functions with respect to position 2 times. Okay, then t square and partial d square and partial x square and psi, this is the capital psi. Okay, and then the phi is constant. Okay, which is not depend on the x, only depend on times, then d divided by dt square and psi, this psi. Okay, then we put these two equations into this list. Now then we will get minus H cut square divided by 2m. Okay, and then d psi divided by d x square and also square, and then plus v and psi and phi. Okay, and here we also write phi. Okay, this ones, and then is equal to iota h cut and psi, and then the d divided by dt of pi. Okay, then we rearrange this equations, which is minus h cut square divided by 2m. Now we separate this equation in term of time and phi and psi, but then we divide this equation by the psi and phi. Okay, this two equation is divide both side by the psi and phi, but then here is only the psi, 1 over psi, the phi is cancelled, and then d squared psi divided by dx square, and then here is only v. Okay, is equal to iota h cut, and here the psi is cancelled and only 1 over pi, and d divided by dt and phi. This is the separable equations. Here only the phi is depend on time, and here only the psi, which is depend upon on the extra. Okay, then let us look here. This is equal to e. Okay, is iota h cut and 1 over pi and d divided by dt of phi, which is equal to e. Okay, then we solve these equations. Now then we divide iota h cut here, and this is the we can write this into this side. This is d pi and divide by this pi. Okay, we write this equation into this side, and then e, and we divide on list is iota h cut, and then the also this side, then dt. Okay, okay, then we multiply here and divide by iota. Then this 2 is iota square is become minus 1s, then d pi divided by pi, and this is minus the iota divided by h cut and to dt. Now we integrate this equation both side. Okay, then here this is the function, and here are its derivative. Then we take the its natural logs. Okay, the natural log of phi. No, okay, and then the integration of this is the natural log of phi. Okay, is minus iota e and divided by h cut. This is constant, and the integration of this is t. Okay, then we take both side by exponential like this. Okay, and then this 2 is cancelled. This is pi, which is equal to e to the power minus I and e divided by h cut and t. Okay, and then the psi, which is and the total psi, which is depend upon the x and t, is equal to only the psi, which is depend on x, and then the phi, which is like this, which is only depend on times. We can write this term. divided by h cut and t. Okay, this is the total wave functions, and the expectations value and its probability is the independent of time. This term is become vanish when we find its expectations value or probability, because here in case of the probability its absolute score. Okay, or then we can also write like this, and psi star. Okay, and then we take the its conjugates, and this conjugate is this become positive and negative become as ones. Okay, this is the as not depending on the time its expectations value as well as the probabilities. Okay, then the Schrodinger equations we can write minus h cut square divided by 2m is 1 over psi. We can write the above equations as t psi divided by d x square d square, and then plus v is equal to e. This term is become equal to e. Then we can write these equations. Okay, then we can write these equations as minus h cut square divided by 2m, and here we multiply both sides psi, and then this term, this psi is cancelled, d psi and d square divided by dx square, and plus here is psi. Okay, psi and e psi, and we can also write like this. This is the total Hamiltonians. Then this is psi and e psi, so which is the time independent Schrodinger equation. Okay, now when the allowed transition between the one energy level to the another, then we must introduce a time dependent perturbations theory. Okay,